Good morning. Today we are going to see a case study in limit of a function. In my previous video, I have uploaded what is meant by a limit of a function, how it is applying for a function. Now we are going to see a case study problem in limit of a function. Limit of a function. Limit means if we are giving any input, we will get an output for the function. We know the definition. Limit extends to a, f of x equal to L. For some types of limit, we have to use a technique called rationalization technique to solve the problem. Some functions is to first to rationalize the numerator of a function. This is called rationalizing the technique. If we want to multiply the numerator by changing its sign itself is said to be a rationalization technique. That is, the conjugate of the numerator and that conjugate should be multiplied and divided to both the numerator and the denominator. My first problem, in order to evaluate the limit of the following rational expression, you need to multiply the numerator. Okay. My question is limit x tends to 16 square root of x minus 4 divided by x minus 16. If I apply the 16 to my denominator, I will get the answer as 0. Okay. So I am going to, similarly in numerator, if I apply x as 16, numerator will also become 0 by 0. So in order to avoid this, I am going to rationalize the numerator by changing the numerator sign. In my RHS part, I had multiplied and divided the value as root x plus 4 divided by root x plus 4. In the numerator, I am having root x minus 4 into root x plus 4, which means it is in the form of a minus b and a plus b. So obviously my formula is a square minus b square. Here the a value is root x. If I am squared root x the whole square, square and root will get cancelled. So my numerator will become only x minus, if I square my b value, that is 4 square means I will get 16. In my denominator, I am just multiplying both the terms as such. So my numerator become x minus 16. In my denominator, x minus 16 into square root of x plus 4. So now I am going to cancel out the like terms in my numerator and denominator. So x minus 16 will get cancelled. I will have only my denominator value, that is root x plus 4. Instead of x, I am going to apply it as 16. So square root of 16 is 4. 4 plus 4, my answer is 1 by 8. So whenever we are getting a value as 0 by 0 while applying a limit, we can use this technique rationalization in the numerator. My second problem is evaluate the following limit. Limit x tends to 7 square root of x plus 2 minus 3 divided by x minus 7. Here if I apply 7, I will get my answer in the denominator as 0. Similarly in my numerator, it will become 0 by 0. In order to avoid this, I am going to multiply my numerator by changing its sign as root x plus 2 plus 3 divided by root x plus 2 by plus 3. So if I multiply both my If I multiply my numerator, I will get square root of x plus 2 minus 3 and square root of x plus 2 plus 3. It is in the form of a minus b and a plus b. A square minus b square. So if I square my first term, square and root will get cancelled. And my second term, if I square 3, I will get 9. I have written my denominator as such. In my numerator, if I simplify plus 2 and minus 9, I will get the value as x minus 7. In my denominator, x minus 7 into square root of x plus 2 plus 3. If I cancel my numerator and denominator as like terms, my denominator will become 1 divided by square root of x plus 2 plus 3. Now I am going to apply my limit as 7. So my denominator as root 7 plus 2. Root 7 plus 2 value is root 9. Root 9 value is 3. So 3 plus 3 value will become 6. So my answer is 1 by 6. So we can apply this technique whenever my limit is equal to 0. My third problem is same as the first and second problem. If I apply my limit, I will get the answer as 0 by 0. So I am rationalizing my numerator by multiplying and dividing. In numerator, it is in the form of a square minus b square. I am cancelling the like terms. Finally, I am applying the limit as 25. So my answer is 1 by 10. So this is how we will find the limit for the problems. The sample problem is given at the end. Thank you.